Okay, so I wanted to talk about the comp exam a little bit because 2 people have already taken the comp exam. I got an email this morning saying that instead of it being due on Wednesday, we're supposed to start on Wednesday and be due the next week. So you have an extension. I'm not going to turn it off because people have already taken it. But I am going to change the due date and not make it due on Wednesday, September 2nd. I'm going to make it due the next Wednesday, September 9th. Okay, so again, the comp exam, to do it, you have to go over to the Math Student Links. And once you're there, it's not under homework because it's not a homework assignment, okay? It's a quiz technically. So you can go to quizzes or tests, and you can also go to all assignments to get to it. And when you're here, it should be right there, the orange one. Okay, so again, you have 50 minutes to take it. The password, I emailed it out on Friday. The password's ready, all lowercase, isn't it? I'm trying to remember off the top of my head. I think it's ready. Yeah, all lowercase. You click on it, you type in your password. There's 10 questions. I believe the 2 people have taken it, or you took it. Can you go back to a question once you finish it?
You can.
You can. I thought you could. I tested it out, but sometimes I have I can do things that you can't. So you can go back to a question once you finish it. Yes, the first attempt is now due on the 9th. Okay, so I will change it. I was just told this morning, so I didn't have a chance to change it yet. So I'll change it on D2L where it's due on the 9th. Once you take it, remember you have to show every single step. If you don't show steps, you don't get credit for the work. Okay, so make sure you show every single step of the problem, and then you submit the work. And where you submit the work is, you go to the content section under, I put right here, comp exam work. So if you click on that, there's an assignment right here. You're going to upload it there. The 2 people that have already done it, I'm going to email you personally. It's you. Anybody else in here done it yet? Okay. It must be somebody zooming in. We also have to upload an honesty statement. So I will post that honesty statement. When you click on it, view, it looks different whenever I do it. But I'm going to create a attachment right here that has the honesty statement, and I want you to write it out on your work, like at the beginning or at the end. I haven't put it on there yet, but it'll say like, I'm doing this without using the help of anybody, without using notes, da, 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 da. So if you'll just write that on your work, and if you've already uploaded, if you'll just write on a sheet of paper and upload it to that right there, okay? And just a reminder that you have to upload your work and honesty statement within about 5-ish minutes of completing the comp exam, okay? So make sure you come over here and upload your work on this area right here. Questions about that at all? Pretty straightforward. Okay, so we are going to take notes. Wait a second. So if you got some paper for notes, we're getting started on actual new material. While I'm here though, remember you have some assignments due tonight at midnight. One review assignment's due tonight at midnight, and then the other one's due on Wednesday. So make sure you're working on those. There we go. Okay. So we are covering section 2.1 today. If you have that yellow packet, you're probably going to need that out at some point today. So remember how I gave you that yellow packet at the beginning of the semester? It had your schedule on it at the beginning. And then it has all this stuff inside of it. This is all the notes I didn't want you to have to write down in class. So we're going to get started on this today. And if you want to really stay on this schedule and keep it up to date, the thing that we have changed is attempt number 1 is not due today. It's now going to be due on September 9th. Okay, so we are going to talk about section 2.1. Section 2.1 is basically functions and their graphs. Okay, so we're going to get started talking about functions and their graphs. If you are zooming in and you never got a copy of this yellow packet, it is on D2L under, I think it's called Unit 1 Notes, under Week 1. So go to Week 1 and click on Unit 1 Notes, and you should be able to see the packet there. Yes, sir.
So this
No. This is like stuff starting on exam 1 stuff. Okay, so this is like the beginning of college algebra. Week 1 was review. Now this is college algebra. So if you'll go to the first page in your notes. There's some definitions there. You can write these in your own personal notes or just keep it here. Okay, so a relation is just a set of ordered pairs. No restrictions on anything. Anything can be a relation, like 2, 5, 6, 9. Like any set of ordered pairs can be a relation. It doesn't have to have a specific relationship. It doesn't have to have any special anything with it. Okay. The domain is all of the x values within a relation, okay? The range is all the y values within a relation. Depending on what you're given, your domain could be like 2 things. It could be 10 things. It could be infinite things. It just depends on the problem, okay? And that's what's gonna make it tricky is when is it infinite? When is it like a certain number of things? Okay, the range is a set of y values. Same thing, could be 2 things, could be 10 things, could be infinite things. A function is a relation in which every x value corresponds to only one y value. So essentially what that means is when I put x in, I get a number out for y. Every time I put that x in, I have to get the exact same number out for y no matter what. Okay, and we'll see some examples of that in just a minute. For most scenarios, things we come across, real life situations, or like equations and stuff I give you in class, most of the time things are functions. Okay, functions behave nicely. We like functions. That's pretty much real life math, but sometimes it doesn't, and so we need to talk about like when it doesn't and that sort of thing. Okay, so let's talk about the different ways we can see functions, like 4 different representations for functions, because that's what makes this tricky is the way I find domain based on the 4 different representations. Okay, so we have 4 different representations of functions. The first way to represent a function, I'm gonna say this is A, is with a set of ordered pairs. So for example, if I gave you this set of ordered pairs, you use little curly brackets for this to show it's a set. And I give you the ordered pairs 1, 2, 3, 2, and 5, 5. On the outside is the curly brackets because it's a set. Okay, so let's find the domain and range of this set. This is the easiest way to find domain and range is when it's a set of ordered pairs. So domain is all your x values. What are the x values here? 1, 3, and 5. And you're supposed to use curly braces when you do this. So 1, 3, 5. Mine are not fantastic, so just do your best. Okay, what's the range for this set? 2, 2, 5. You only have to write the 2 one time. You don't need to repeat anything. So just 2 and 5. The last question is this a function? So just a reminder, a function is when you can put a number in for x, get that number out. If you put that same number in for x, you get the same number out. Okay, you can't end up with 2 y's for 1 x. Okay, so I put in 1, I got out 2. I put in 3, I got out 2. I put in 5, I got out 5. Is this a function? It is a function because I put in 1, I got out a number. I didn't put in one again and get out a different number. That's the issue, is when you put in the same number and get out a different answer the second time. Okay. And which in life like that, you don't want that to happen anyways. Like, is this assignment due today? Yes. Is this assignment due today? No. Like, we need the same answer every time you ask the question. Okay. So this is, yes, it is a function. It's okay to get the same number out. Like the same y value to happen. It's when you have the same x value with two different y values is the issue. Okay, so let's do another one just to show you what's not a function. So if I had 5, 6, 5, 7, 6, 6, and 6, 7. What is the domain here? Yeah, just 5 and 6. Those are the only x values we have here. What's the range here? 6 and 7. Is this one a function? This one is not a function. I put 5 in and I got 6 out. I put 5 in it again, and the second time I got 7 out. Okay, so like the idea of like putting it in and getting it out is like if we had an equation. So let's say my equation was y equals, here you go, x plus 1. That works for this. Okay, so I put in 5. Y equals 5 plus 1. What do I get? I got 6 out when I put it in. Let's say I put it in again, and for some reason, x plus 1, and I put in y equals 5 plus 1, and this time I got out 7. Like, I can't get out 7 by adding 1 to it again. Does that make sense? Like, that's why it's messed up. There's not really an equation. Well, there are some, but for the most part, there's not really equations that happens to. Okay, so no, this is not a function. There's a couple of different ways you can explain why it's not a function. You could literally say, putting 5 in can't get out 6 and 7. A lot of people say x values repeat. If you're looking at a set of ordered pairs, you can't have the same x values repeated, because if you have a set of ordered pairs and the x value is repeated, that means you got a different y value out. Okay.
Are we always going to be asked to explain that?
Yeah, I think they usually ask you why. Questions about that? Okay, so that's one way you can see a function is a set of ordered pairs. It is not the most common way. Like, for the most part this semester, we're not going to have sets of ordered pairs for our functions. The reason why not is because our functions are going to have infinity ordered pairs. So I could never list them out on a piece of paper, but you can see functions that have sets of ordered pairs. Another way to see a function is as a mapping diagram. So this is the second way to see a function. It's called a mapping diagram. Okay, a mapping diagram is similar to ordered pairs. It's just a picture, essentially, of ordered pairs. Okay, so for example, we'll call this number 1. If I had, actually, whatever. If I had, it's like 2 circles or 2 ovals, or sometimes they're rectangles. It just kind of depends on the problem. And in the left-hand side, that's all my x values. And the right-hand side, that's all my y values. So I have the x values of 0, 1, 2, and 3. I have the y values of 3, 5, 7, 9. And the way you know which ones go with which is there are arrows. So 0 goes with 3. So I'm going to draw an arrow from 0 to 3. 1 also goes with 3. So I'm going to draw an arrow from 1 to 3. 2 goes with 7. And 3 goes with 9. I'm sorry, 5. I don't know why I said 9. Okay, what's the domain here? What x values are being used in this problem? 0, 1, 2, 3. Those ones with arrows, right? The range, which y values are being used in this problem? 3, 5, and 7. 9's not being used, right? It's just an extra one. So 3, 5, and 7. Domain and range is still pretty straightforward. The hard part is deciding if it's a function or not. Okay, so the idea is when I put an x in, when I put 0 in, when I ask the question of what is y when x is 0, do I get the same answer every time I do that, or do I get a different answer sometimes? When I put in 0, what do you get? 3, because the arrow always goes to 3. When I put in 1, what do I always get? 3. When I put in 2, what do I always get? 7. When I put in 3, what do I always get? 5. Is this a function? Yes, it is a function. Think about what does it need to look like for it to not be a function? I'm about to give you an example of it, but I'm gonna see if you can come up with it on your own. 2 arrows coming out of the same number on the x. Okay, it's okay for 2 arrows to come over here on the y, but I can't have 2 arrows coming out of an x. Okay, so let's do an example like that. Just real quick. So this is the x, this is the y. Let's do the same numbers, 1, 0, 1, 2, 3, 3, 5, 7, 9. This time we're gonna say 0 goes to 3, 0 also goes to 9. 1 goes to 3, 2 goes to 7, 3 goes to 5. Okay, we could do the domain and range again. Do you need to do it again? It's pretty much the same. How's the domain and range different this time than it was last time? You're using the 9, so would that go in the domain or the range? The range. The big thing I want to know here, is this a function? No, it is not. Why is it not a function? No, because 0 is paired with what 2 numbers? 3 and 9. You can't ask the question, get out 2 different answers whenever you shouldn't. Sometimes it happens, but if we're going to be consistent, it shouldn't happen, right? Okay, so let me show you one more that looks kind of weird. If I had this mapping diagram, 0, 1, 2, 3, and only the number 5 over here, and every single one of these numbers went to 5. What's the domain? 0, 1, 2, 3. What's the range? Just 5. Is this a function?
Yes.
Yes. Okay, and I can tell you what the equation is. The equation there is y equals 5. When I plug in 0 for x, is there even an x to plug it into? No, the answer is just 5. When I plug in 1 for x, the answer is still 5. No matter what number I plug in, the answer is always 5. Okay. Okay, so that is mapping diagrams. Questions about that? Pretty straightforward. Where it kind of gets a little bit tricky is when we talk about graphs and equations, and that's actually what we're spending basically the whole semester on, is graphs and equations of different types of functions and all the specifics about them. Okay, so let's talk about graphs first. So the third representation is a graph, or the third way to represent a function. We can represent with ordered pairs, we can represent with a mapping diagram, we can represent with a graph. Okay, so domain and range is harder with graphs than it was on the last 2 problems. Why is it harder on graphs than it was with the last 2 problems? How did we write our domain and range on the last 2 types of problems? A list, right? We just listed out all the x values and all the y values. On a graph, can you list out all the x values and y values? No, you cannot list them out because there are infinite points that make a graph. That line on your graph isn't just this pretty solid line that somebody drew. It's infinite points, infinite dots that are put together to look like a line because there's so many dots all close together, okay? So you cannot list domain and range here. You have to show the infinite amount here. And what's the only way I can show an infinite amount? You can't list it out. You have to use interval notation. Okay, so interval notation is the whole infinity or negative infinity to 3 with a bracket or a parenthesis, right? So something looks like this, negative infinity to 3, or, 5 to infinity. So let's like do a real quick recap on how to do that if you forgot. What does a bracket mean? A solid dot. The graph exists at that point. What does a parenthesis mean? Open circle. It's like on a graph, it's an open circle showing that like it goes all the way up to that number, but it doesn't quite exist there. So in this example, 5 not included. So like 5.00001. We include that number, but we don't include 5. It's like your brother, like, I'm not touching you, but they're as close as they can possibly get. Okay, so that's the idea of the parenthesis. So 5 to infinity, that's all the numbers bigger than 5. Okay, so interval notation is how we use to show it on a graph. Let's go ahead and tell if something is a function first, and then we'll do some examples going back to your handout. How do you tell if something's a function on a graph? What do you know what it's called? Vertical line test. Okay, so the vertical line test is how we know that a graph is a function. The vertical line test says, draw vertical lines. You can draw technically infinite vertical lines on your graph. It is only allowed to touch the graph once to be a function. Okay, so draw vertical lines. This is actually on your notes if you saw it earlier. It's right here. If any vertical line intersects a graph in more than one point, the graph does not represent a function. Okay, so your idea here is draw vertical lines. Only allowed to touch one time. If it touches more than one time, it is not a function. Okay, we are going to practice writing some domain, range, and interval notation and deciding if it's a function or not. So look at 6 through 12. I'm gonna zoom in. Again, if you're zooming in and you don't have a copy of this, this is available on D2L. So look at number 6. That is a line segment, right? It doesn't go on forever each way, but there still are infinite points on that. It's not just the points that are on the little cross sections of the graph, like all the points in between. I could do like decimal points all the way through here. Okay, so to tell the domain is x values. What x value does this graph start at? What x value does this graph end at? It starts at -3 and it ends at 2. So the idea here for domain is like, how wide is your graph? It's from -3 to +2. We need to use brackets or parentheses. For the -3, is that going to be a bracket or a parenthesis? Okay, let me see if I can write really small. So for -3, it's a parenthesis because it is an open circle there. All the way over to +2, is that a bracket or a parenthesis? Bracket, because it is a closed circle and it is filled in. Questions about that? Okay, the range is the y values. Again, just a reminder, you go from, like on domain, you go from left to right because it's smallest to biggest. On range, you do the same thing, but this time we're going from bottom to top because the smallest number is on bottom and the biggest number is on top. So what's the lowest y value on this graph? 1. At 1, is it included or not included? Not included. It needs to be a parenthesis because it's an open circle there. What's the highest point on this graph? Y value? 2. So notice we're using Y values to tell a range. Okay, so my range here is 1 not included to 2 included. So the range tells the height of the graph. The idea is like if I was going to find a box to fit this in, the box needs to be front like this width from -3 to 2 and this height from 1 to 2. Does that make sense? Okay, is this a function? Yes, how do you know? Because when I draw a vertical line, is there any way to draw a vertical line to make it touch more than one time? No, it only touches one's right there. If I do it right there, it only touches once. There's no way to draw a vertical line and make it touch more than one time. Okay, so yes, this is a function. Questions about that? Look at number 7. This is another, it's not a line this time, it's curve, but it's a segmented curve. It's not infinite. Take a second and see if you can do domain and range there. Okay, the domain. What x value does this graph start at on the left? -2, that's included. Where does it end at on the right? +1, that is not included. That's how wide it is from -2 to 1. The range is how tall it is. What's the lowest y value on this graph? 1, all the way down here at the bottom of the curve. What's the highest y value? 5, all the way up here at the top. Those are both included because neither one of those had an open circle. So the range is from 1 to 5. Is this a function? Yeah, if you draw a vertical line, if I draw one right here, how many times, that's not really vertical, but you know what I mean. How many times does it touch? Just one time. If I draw a vertical line here, it only touches one time, so on and so forth. Questions about that? Look at number 8. This one's a little bit different because this one's infinite, going one direction. Okay, so the domain here, you read domain left to right. Where does this start out on the left? What x value? -infinity. What x value does it end at on the right? 4. Is that included or not included? Your range. What's the lowest point on this graph? So it's this dot right here, but you look at the y value, which is 0. Okay, so it goes from 0 included to, how high does it go? +infinity. Arrows tell you it's an infinite answer on the domain and range. Is this a function? Yeah, everywhere you draw a line, it only touches the graph one time. So yes, this is a function also. Okay, number 9 is kind of crazy. This is called a step function. So a step function says that, okay, so like at the x value of 1, your y value is 1. At the x value of like 1.1, your y value is 1. 1.2, it's 1. 1.3, it's 1, right? 1.5, it's 1. 1.9999999, the y value is 1. At 2, there's an open circle at this point, and it jumps up here. So at 2, your y value is 2. 2.1, it's 2. 2.5, it's 2. 2.99999, it's 2. When you get to 3, it's no longer exist at 2. It jumps up to 3. Does that make sense? So there's technically infinite things on this graph, infinite points, but they look weird. Okay, so domain. Your domain for this problem, what x values do we have? 1, 2, and 3, and all the numbers in between those, right? And like all the threes too, like 3.1, 3.5, 3.999. So I can't just list that out. I have to write that in interval notation, right? So it's going to be from 1, would I include 1? Yeah, because there's a dot there. To 4, because I need to do 3.99999, but 4 is not included. So it's from 1 to 4, not included. Oh, sorry. Okay, so if you are going into math past college algebra, you'll be spending some time on functions like this. This domain is an interval because there's infinite points here, infinite x values. And this interval I can write as one thing here, but that is, would you say that's a continuous function? It's not continuous because I have jumps. Like you heard me say, then when I get to 2, I got to jump up to 3. That's like not a continuous function. That's a huge thing in calculus. So if you are going past this class, like be ready to talk about that more later on. Okay, range. What y values did we get out when we talked about 1, 1.5, 1.9, 2? 1, 2, and 3. Those were our 3 answers. Is there a way to get a y value of 2.5? No, because I could only get 2. So the range I actually can list this time because it's just 3 numbers, 1, 2, and 3. So kind of weird. Here's the weirder question. Is this a function? It is a function. Okay, so when I draw a vertical line here, it only touches once. Here at the dots, I draw a vertical line. Does it actually touch it at the bottom on 1? No, because it's an open circle there. It only touches it up here. Okay, so yes, this is a function. It is not a continuous function, but it is a function.
So with this kind of function, we can list the ranges as the only one.
Yeah, that's about the only one on the graph, unless you had like a bunch of random ordered pairs. Okay, so look at 10, 11, and 12. We're not going to do domain and range here just because there's not numbers on this graph. I was really doing this to show you all those ones above it were all functions. I want to show you some that aren't a function. Okay, so look at number 10. Is that a function? I'd say it probably is. You could argue this whole thing right here. If we zoomed in super duper close, I think you could see it's kind of like it looks like everywhere it's only touching one time. So yes, that technically is a function. If it's not a function, it's gonna be very obvious, like number 11. Is number 11 a function? For sure, no, because when I draw a line through it, it touches 1, 2, 3 times. Look at number 12. Is that a function? Yeah, it's weird looking, but it only touches one time everywhere. Okay. That's everything about graphs. Okay, let's move on to, let me zoom way back out. Let's move on to the last representation, which is equations. Okay, we're going to go pretty quick through this because this one's pretty obvious. The way for equations, at this point, you do not need to tell what the domain and range of an equation is because at this point you have learned everything. That's why we're going through all the different types of functions so that at the end of the semester you can say, I know that domain and range, I know that domain and range, so on and so forth, okay? The idea right now is just is it a function or not, looking at the equation. And is it a function? And I told you earlier, for the most part, most things are functions. Most equations you get are functions. For example, y equals 2x plus 7. If I plug a number in for x and get a number out for y, if I plug in the same number for x, am I going to get a different number out for y? No, because every time you plug in 1 and multiply by 2 and add 7, you're going to get the same number. You should, right, if you're doing your math right. The only time that an equation is not a function, there's very few situations. One situation is when you have an equation that looks like this, x squared plus y squared equals 4. Sorry. Let's pick a number and plug it in for x. Let's plug in, let me think of a number that's actually going to work nicely for this. Let's plug in 0. Plug in x equals 0. When I plug in 0, I get 0 squared plus y squared equals 4. What is 0 squared? 0. So this is just y squared equals 4. How do I solve for y? Take the square root. Remember, if you put a square root in a problem, you got to put a plus or minus in front of it because it technically could be positive or negative there. So my answer is y equals plus or minus, what's the square root of 4? 2. So that means I got 2 ordered pairs right there. When I plug in 0, I get out positive 2. When I plug in 0, I also get out negative 2. Is that a function? No, it's not a function. It's mainly when you have y squared. That's when it's not a function. Okay. Do you know what that graph is? X squared plus y squared equals 4. Took algebra 2 in high school. Parabola is x squared. What about if y squared? Y is squared also. It's a circle. So does that make sense why it's not a function? Because it touches 2 times. Okay. That's the gist of domain range, and if it's a function, no matter how it's given to you, if it's an equation, if it's a graph, if it's whatever. The last things we need to talk about, I'm not gonna have time to finish this, but we're going to try. We need to talk about function notation. Okay, function notation is f of x. Okay, that's read f of x. The x is the domain. The range is f of x when I put in x into my function. And remember, f of x is just basically y. Fancy way of writing y. Okay, let's do a few things here. I'm going to give you the function for the next 3 problems. F of x equals 3x squared minus 2x plus 5. That's going to be our function for the next 3 problems here. Okay, so the first thing we want to do, let's find f of negative 5. To find f of negative 5, what does that mean? Plug in negative 5. So I get 3 times negative 5 squared minus 2 times negative 5 plus 5. Work it out, get your answer. 3 times negative 5 squared. Do I multiply by 3 first or square it first? Got to square it first. You can't multiply by 3 first because of order of operation. So what is negative 5 squared? Positive 25. And then I can multiply everything out. What is 3 times 25? 75. Negative 2 times negative 5? Positive 10 plus 5. And what's 75 plus 10 plus 5? 75, 85, 90, right? So f of negative 5 equals 90. What's the order of pair that goes along with that? What's the x value there? Negative 5 is the x value, 90 is the y value. So negative 5, 90, right? What about if I asked to find f of negative x this time? That's weird. What's f of negative x? What does that mean? What's the problem asking you to do? Put in negative x for every x you see, right? It's kind of weird. Then you're going to see why we do this in a minute. Like, end of this week, next week. Okay, so in my equation, 3x squared minus 2x plus 5, I'm just going to stick in negative x everywhere I see an x. So 3 times negative x squared minus 2 times negative x plus 5. Sometimes, not always. Okay, so again, I got to square it first. What is negative x when I square it? It turns into positive x, right? Positive x squared. So this would just be 3x squared. What's negative 2 times negative x? Positive 2x, and then just plus 5 at the end. Okay, so that's for f of negative x. Look at where you started, 3x squared minus 2x plus 5. Look at where you ended, 3x squared plus 2x plus 5. What changed? Just the b value, just the 2x. 3x squared didn't change, 5 didn't change, just that one did. That has to do with being an even or an odd function, and we'll talk about that later on, like Friday or Monday. Okay. Last one we're gonna do on function notation is f of x plus 2. What does that mean, f of x plus 2? You put in x plus 2 everywhere you see x. So this would be 3 times x plus 2 squared minus 2 times x plus 2 plus 5. First thing you have to do is this x plus 2 squared. Can I just square the inside and just be x squared plus 4? No, what do you have to do? You gotta like FOIL it out, right? Write it twice in FOIL. X plus 2 times x plus 2. This is why this is on your comp exam. Okay, so you gotta be able to multiply binomials. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Add or combine like terms, so you get x squared plus 4x plus 4. That's what I'm going to put in for the x plus 2 squared. So this is 3 times x squared plus 4x plus 4. And then negative 2 times x plus 2. And then plus 5. Okay, so now distribute the 3. So 3x squared plus 12x plus 12. Distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4 plus 5. Combine like terms. And I get 3x squared. I can put together the 12x and the negative 2x to get 10x. And then 12 minus 4 plus 5. 13. So f of x plus 2 is equal to 3x squared plus 10x plus 13. Okay, last thing on this section we are going to finish. We're going to do it real fast. Look at number 19 on that handout. I can't go that close. There we go. Okay, so using this graph, we're going to find these things. Our lesson on Wednesday, we're going to add to this list of things. And like on your test, you're going to be given a graph like this and have to answer like 12 things about it. So break it into pieces. Starting off with this. Find, this is g of x over here. Find g of negative 4. What is that asking for? What did that tell you? X is negative 4. What are we trying to find here? The y value. So at the x value of negative 4, I go up to the y value. What's the y value there? 2. So g of negative 4 equals 2. G of 2. How do you find g of 2? Go to the x value of 2. Go to your graph. What's the y value there? -2. G of -10. Well, crap, that's not on the graph. How am I going to know? This arrow tells you it goes forever right there on that line. So at G of -10, way over here, what would the y value be? 2 still, right? At G of +10, same thing, but on the other side of the graph. So way over here at +10, what would your y value be? -2 still. 2 minutes, we're almost done. For E, for what values of X is G of X equal to 1? That's different than the question above it. What is this question asking for? Y is 1 this time, you find X. So where is Y1 at? About right there, that dot right there, which would be -2. So this is where X equals -2. For what values of X is G of X equal to -1? This time it says Y is -1. Where is X? What's your X value? So you go over to -1 right here. What's that X value? +1. So X equals +1. What's my X-intercept on the graph? And you got to write as an ordered pair. So 0, 0. What's my Y-intercept on the graph? 0, 0. We finished with seconds to spare. Okay, so like just a heads up, this is where we're headed. After we learn Wednesday's lesson, we can do this. Looking at that graph and answer all these questions about it. So we like did the kind of the first of those questions. Okay, so work on your homework. You can go ahead and take your comp exam now, but technically you don't have to start till Wednesday taking it. Let me know if you have any questions, and I will talk to you, or I will see you on Wednesday.